Okay, we're live. Hi everyone, welcome to this week's Antrea live show. Today we have Yang Ding and Grayson with us, and they're the old friends of Antrea Live because they were here when we did the first episode. So for the new audience who just joined the show with us today, Yang Ding and Grayson, would you like to do a self introduction shortly for them?
Yeah, sure. So my name is Young, and I've been mainly working on the policy side of things in Antrea. So I've been the part of a lot of the big Antrea native policy features. For example, all the Antrea native policy features. I would say I've basically been involving in developing these and maintaining these, and I think that's also basically the case for Grayson as well. So we're excited to be here to present some exciting features of the Antrea policy.
Yeah, thanks, Yang. You basically helped me to introduce myself. Now I only need to say I'm Grayson. Yeah. Thank you.
Okay. Okay. Well, welcome back, Yang and Grayson, with this great features for the Antrea 1.6. I heard that we already have the network policy support in a previous version, but this time we have a improvement of that, right?
Right. So for the Antrea policy, it has been around for a long time, and we're constantly adding new features into the Antrea policies. So for example, we have recently, I believe we have something like FQDM policies, policy to services support, stuff like that. I know Grayson Qiyue, who is also on our team, and myself included, are working towards these features, and we're excited. So this becomes a complete feature set of the Antrea native policies. We'll basically try to cover as much as possible today in this Antrea live demo, and we'll see how it goes.
Awesome. So, would you like to go ahead and tell us a little bit context about the network policy, and then?
Yeah, sure.
Okay.
Yeah, cool. So also, I guess as a reminder, the audiences can also post questions in the live chat, right? So would you take care of drawing these questions to our attention if anything arises?
Yeah. For the audience, please sign into YouTube so you can comment in the comment chart, and we can see that, and maybe we can answer any questions you have during the show time, and you can just say hi to us to let us know that you are here.
Yeah, hi Jingjing.
Hi Jingjing.
So let me get started real quick. Let me try to share my entire screen. Okay. So okay. Let's wait here. Okay. So to introduce the Antrea native policies, we wanted to first take a step back and do a really quick review of what the Kubernetes network policy does. So in Kubernetes OSI model, if there are no policies whatsoever in a cluster, by default, Kubernetes prescribes that all pods can definitely talk to each other, without any, DNAT on everything. They can just, connect to each other using their IPs. But the network policy come into place where a developer might want some sort of like security postures imposed on some of their workloads. A really typical use case is that some pods are deployed as part of some services, and people wanted to control what other pods or what other maybe external siders can talk to these services, and the how they can achieve that using the Kubernetes OSI network policy model is that they will apply certain network policy onto these pods, So you can see here, this is a very basic sample network policy here. It basically, the network policy is a namespace resource. So this specific network policy applies to all DB pods in the default namespace. And it has, a bunch of ingress and egress rules saying what are the ingress that are allowed for these pods and what are the egress allowed for these pods. A really important thing to take into consideration for this network policy model is that it is a allow list based model, and it has a implicit isolation behavior for all the pods that are selected by the policy. By implicit isolation, I mean that once a pod is selected by some network policy, uh, and it has a policy type of ingress or egress or both, right? So in this specific scenario, it has both ingress and egress rules, meaning that ingress to this pod or egress from this pod are implicitly denied when there's a policy like this in place, except for something that is explicitly allowed, which is specified in the network policy rules. So in this case, we are selecting the DB pods, and we're allowing ingresses from specific CIDR, from a specific another namespace, which matches this criteria, and we're also allowing ingress matching this specific criteria in the same namespace from these pods on specific ports, obviously. So this is how the Kubernetes network policy works. But a lot of discussions has already come up in the SIG network SIG space in the upstream Kubernetes, because obviously a lot of cluster admins would want to control some traffic in their cluster on a namespace level, right? So a very typical use case. I will show my terminal here, I guess, because I prepared a really simple Kubernetes cluster to showcase the Antrea native policies today. And
A quick question, Yang. So, can you go back to the previous?
right.
Yeah. So if I don't have the ingress rule and egress rule defined it below, I only have the policy types to in like ingress and egress. Is that means that the pod cannot be reached by anyone, any other pods, and the pods cannot talk to any other pods, right?
Yes.
And the network policy is like created in the default namespace. So does the pod in the default namespace that's selected by the pod selector is affected by this network policy, right?
Yes.
So
and
if
you can specify which namespace the network policy belongs to.
yeah, if I have another pod in a different namespace and also have the role equals to DB label, it will not be influenced by this network policy.
Yes.
Okay, gotcha. Thank you.
Okay. Sure. Let's move on a little bit. So I've prepared a sample cluster in the Kubernetes, and it has some workloads deployed in 3 different namespaces other than the system namespace. So we got a dev US East namespace, a dev US West namespace, and a production US West namespace. So what I can tell you is that the dev US East and dev US West has label app or type equals dev for the namespace. And this guy has a type equals production label for the namespace. And for each of the 3 namespaces, I've basically deployed the same deployment, which is a client deployment, DB deployment, and web deployment with app equals client DB web as a label for each of them. So it's really sort of like a minimalistic and simplified version of how some production Kubernetes cluster can look like. Now, a typical use case we've been asked by Antrea customers or any, I guess, CNI customers really often is that I want a namespace isolation between my tenants. In this specific case, the tenant can map to a specific namespace. So in other words, people, the cluster admins may want some policy in the cluster saying that, hey, I want all pods in the dev.us East to only talk to dev.us East pods, and pods in dev.us West to be only able to talk to dev.us West pods, and the same thing for production US West. Now, if you wanted to enforce something like this using the Kubernetes network policy I just mentioned, it will be really hard because the network policy resource is not designed for a use case like this. So a custom admin would need to write some sort of like controller, which does the following. It needs to go into each of the namespaces here and select everything in the namespace and says that for ingress and egress, I wanted to allow only stuff in my own namespace. And for such a policy, it needs to be created in each of the workload namespaces that are present in the cluster. So, which means that once a new namespace come up or something similar, the controller needs to go into that namespace and create another Kubernetes network policy resource for that specific use case. And so that's another sort of like layer of policy definition on top of the resource itself. So which is not really user friendly.
Are you saying that the cluster administrator need to develop that controller by themselves?
Most probably, I would guess there are some sort of like controller that does that. You can probably find some GitHub repo that does that. I'm not entirely sure, but I also would imagine that people who need this feature would also use a CNI such as Antrea, which supports cluster level network policies. So this basically automates that for them.
Okay, so the Kubernetes network policy is only like the namespace level. So if you want to apply the same policy to different namespace, you have to do that one by one to each namespace, right?
Yes, exactly.
It's very inconvenient to use.
Right. So this is the first. This is a first caveat I want to mention about Kubernetes network policy. The second caveat is its implicit isolation behavior, right? So as long as in the namespace there are some developer which applies some network policy onto the workloads, it becomes implicitly isolated other than something that's explicitly allowed. So a lot of times people often forget to put DNS into the ingress and egress rules. And when they apply some sort of network policies, they suddenly realize that, hey, DNS doesn't work anymore. And they will be searching down the rules to find out what am I missing here, but they're not missing anything explicitly, they're just missing it implicitly, because with this policy specifically, for example, ingress and egress DNS are implicitly denied because they are not explicitly specified in the rules. So in other words, if you apply this policy onto the row equals DB pods, you will see that the DB pods will not to be able to resolve something like google.com. And in Antrea native policies, we are basically changing that behavior so that anything people wanted to say, whether it's a allow, deny, or reject, will needs to be explicitly written out in the rule so that we don't run into the same problem with the existing Kubernetes network policy. Does that make sense so far?
Yes, but I'm curious, like how you define the roles in the Antrea policy now.
Okay, cool. So let's take a look at the example Antrea network policy, which I've prepared here, called the strict namespace isolation. This is a cluster level Antrea cluster network policy. And as you can see in its name, it's called strict namespace isolation, which means that it does what I just told you about. It isolates each workload namespace so that the pods in each namespace can only talk to their own namespace. And this is how the cluster network policy will look like. With this single resource, every namespace in the cluster can only talk to the pods in their own namespace with this one single YAML. And then we'll walk you through what it does right now. So a cluster network policy, obviously like other Kubernetes network policies or other Kubernetes objects, will have a name and a spec. So in the spec, you will have two things that are basically determining the priority of the cluster network policy compared to the others. The first differentiating factor is the tier here. So on Antrea startup, we create 6, I believe, static tiers, which are defined using CRDs that people can refer to for cluster network policies. There are application, security ops, network ops, and emergency. And there's something else. I forgot its name. But essentially, these tiers has inherent priority among the others. So what you've every cluster network policy created in the security ops tier will have higher precedence than the cluster network policy created in application tiers. So by doing this in a tiered fashion, we can ensure that once, for example, when the cluster admins wanted to create some cluster network policy more related to the application layer of logic of things, they would not be able to overwrite those policies that are more demanding, which is for security purposes. And as the naming suggests, if you create something in the emergency tier, that will be basically of the highest precedence, and it will override any other cluster network policies in the other tiers. Now, within a tier, people can also specify the priority of the policy by putting a priority number. So the lower the number is, the higher the precedence will be. So a priority 1 policy will be of really high priority precedence, and the 5 will be like a medium priority in that sense. So this is, sorry, go ahead. Is there any question?
So if I create a Kubernetes network policy, which tier it's in?
Right, that's a good question. So a Kubernetes network policy is not associated with any Antrea tier. So how this works is that let me do a really quick doc check for you guys. So you can refer to this specific document if you have any questions regarding the Antrea native policies. But for the tier CRDs, you can see here that these are the tiers that Antrea creates for you automatically. And all of the policies in those tiers have a higher precedence than Kubernetes network policies, except for a specific tier, which is called a baseline. Every policy that's created in that specific tier will have a lower precedence compared to the Kubernetes network policy. I will cover what the baseline tier does, but basically it is a way for people to specify a different security posture for the cluster to begin with. So as I mentioned, by default, every pod in the Kubernetes cluster can talk to each other, and that's the default behavior. People might want to switch that up so that they have a different default behavior in the Kubernetes cluster, but they want that default behavior to be overridable by developers. In that specific case, policies can be created in this baseline tier. Otherwise, if they wanted to impose something that is more strict or non-overridable, they can impose this policies into these specific tiers, so that they ensure that no matter what network policies are created by developers, they cannot be able to override the cluster network policies created in these tiers, if that makes sense.
Yeah. So for the generally speaking, that the Antrea policy has like the higher priority than the
Yes.
Kubernetes network
Yes.
policy, right?
Yes.
Okay.
Okay. Moving on to the spec. Okay. Quick one. Is there any other questions in the comments? Let me just quickly check that.
I think we don't have any questions
Okay,
right
cool.
now.
Cool.
And let's say hi to the Ricardo, Vivek, and Salvatore. Salvatore, welcome to welcome to this week's show.
Okay, I'll move on to the spec of the cluster network policy then. So just like the Kubernetes network policies, a cluster network policy can have ingress and egress rules. Now remember that every rule needs to be explicit. So if there's no egress rules, it doesn't really mean that egress is denied by default for this policy. It doesn't really mean anything. So every rule basically needs to be explicit here for Antrea cluster network policies. Now let's take a quick look into the ingress rule here. So the first ingress rule here says it is a pass rule. And let me explain this pass rule here. Because we have a second rule here, which is dropping every ingress from pods from all other namespaces. The pass rule in the front, which has a higher, this rule has a higher precedence than this rule, obviously. And then this rule here, when it's saying a pass, it's trying to select something, and for the traffic matching those, these traffic will not be subject to the drop rule that is mentioned below. So it's like for every traffic matching this specific ingress peer, basically for every traffic that's from here to whatever it's applied to, this will skip the ACMP evaluation, if that makes sense. I think I skipped the apply to field here. Let me back up a little bit so that people will be easier to understand this. So the apply to here is basically like the path selector field in the Kubernetes network policy. But because the Kubernetes network policy is a namespace bound resource, you can only specify pods in that specific namespace, but you cannot specify namespaces because it's a namespace resource. Now, for the Antrea network policy, cluster network policy, it's a cluster scoped resource. So you can really specify what are the namespaces you want this policy to be applied. And in these namespaces, you can even go further and specify the path selectors within those namespaces you want this policy to be applied. For this specific resource, it basically selects every namespace that are not kube system. In our example here, it will select all the namespaces which are not kube system. So what I'm highlighting here, right? So this is what the policy applies to. Now, for the ingress rule, let's look at the first ingress rule here. It says that I want to pass every namespaces that matches self. And this is more like, a syntactic sugar, if you will, for the ingress rules. And it has a really strong expression, which basically just means the self namespace in this context. So let me expand a little bit more on what this means. because we have three different namespaces here, right? So when we are evaluating this particular policy for this specific namespace, uh, that specific policy rule which matches self namespace means every workload that are in this namespace and nothing else. But when we are evaluating the same policy for this specific namespace, the namespace equals self matches every pod in this specific namespace instead. So when we look at the policy as a whole, this specific ingress rule is saying that for each of the namespace selected in the apply to, the this first rule selects everything that is in the same namespace of that specific namespace, which is selected by the apply to. And the second rule here is saying that I'm passing everything that's related to the Kubernetes kubedns part. So with these two rules, what will happen is that these two peers are not affected by the drop all rule that's specified below. And what it means is, that, for this specific namespace, I'm dropping everything ingress except for two different things. One, if the traffic is coming from my own namespaces, which is something like when a client pod wants to talk to a web pod in my own namespace. And this traffic is not affected by the drop rule. And the second one is the DNS thing. So if I try to resolve google.com from my client pod, it will basically send a DNS request to the kube system DNS components. And when the result comes back, it will not be affected by the drop all rule. It will still go through. Other than these two kind of traffic, everything else will be denied. And the same is true for the two other namespaces, because for the other two namespaces, the match equals self will resolve to different network peers for those two namespaces. And the end result, by applying such policy, will be that each namespace will be isolated on its own, so that only the pods in its own namespace can talk to each other, but everything else on the other on the outside will be isolated to these namespaces, except for DNS components. And essentially, this is what this policy is saying. And you can see that it has the same rules for ingress and egress. So there is some symmetry there. And by applying this specific namespace isolation policy, no matter what new namespaces come or go, this policy can ensure that as long as there are workload namespaces, when they come up, they're automatically isolated. And when they're deleted, sure, the Antrea policy would not be covering that namespace anymore. But in short, every namespace that exists in the cluster will be enforced ALI isolation policy. I will pause there to see if there are any questions on this regard.
I think Jay has a question.
Yeah,
So
sure.
what's the Venn diagram between an Antrea policy upstream and the main policy?
A Venn diagram between a Antrea policy and a. Sorry, I was just trying to see the.
The last one.
Okay. The main. Oh, okay. I see what the question is asking. So there is actually a upstream effort we're making, which is merging a specific resource called admin network policy in the Kubernetes upstream. So shout out to Abstract also for starting this effort. But right now we're currently still deciding how this admin network policy will come to play side by side with the current Antrea native policies. So I cannot tell you an exact answer right now, but yes, this is something to also to watch for, because this will be the Kubernetes upstream version of the cluster scope network policy. If that answers the question.
Yeah, I think it's like very clear. And is there any questions about the spec of this cluster network policy? Okay, I guess we're good to go to the next section.
Okay. So I just wanted to quickly mention a caveat here. So the reason why I put this specific expression for the apply to of a cluster network policy is that you probably wanted to be really careful if you wanted to apply this policy to all namespaces blindly, because if you apply this to all namespaces, chances are there are also some system components that are also affected by the policy. In this specific example, if you apply this policy to all namespaces, you can apply these policies onto the core DNS pods as well. The end result of that is that for the core DNS pods, it will only accept traffic from its own namespace, which is kube system, or the core DNS pods, which is itself, which doesn't really make any sense, and it will drop everything else. Now, what that will mean is that whenever some clients in the same cluster are trying to do some DNS resolving, that request will get dropped by this cluster network policy, and it's not ideal. So that's why in the demo here, I put this specific expression so that we make sure that this cluster network policy is only applying to the workload namespaces, which is what it's supposed to operate on. Okay, so let's.
I also noticed that in the action there's pass and allow. So is there any difference between them?
Oh, right. So as I mentioned, the pass will basically just skip the rule evaluation for this drop rule, so that these traffic will not be affected by the drop rule below. But for the allow rule, it will be something more strong. It will be like, I wanted to explicitly allow egress towards these towards this service, and there's no way there's other lower level policies can override this behavior unless there's a deny rule that's of higher precedence than the specific policy. So in other words, allow is a strong allow, and the pass is like for this specific traffic, for my specific policy, I don't really care. I wanted to pass it along to other policies that could potentially change this behavior again, but that's not on me. Does that make sense?
Yeah. And there's also like, so the lines that you highlight just now, there's like a two service spec. Is that like a new one in the Antrea policy?
Yes. It's a new feature added. I think in the 1.5 release, if I remember correctly, or the 1.4 release. So that this is a really cool wrapper if you wanted to allow or deny or reject any traffic towards a specific Kubernetes service. You can just put a name and namespace there, and it will resolve to that service. So you don't have to put any pod selectors and put the service ports in the port section. This two services field will automatically resolve that for you.
Yeah, awesome. And this is actually the first place that I see that two service label here.
Yeah.
Okay. Let's see.
I just want to add a little bit comment on this field. It's when you use that, there's a little caveat since the two services only select the. It rely on the Antrea proxy. So if we so the Antrea will do the load balance for these services. So if you connect to the backend endpoint of these services, it will not be selected by this policy. It's if you want to realize the backend endpoints selection, there's another approach in cluster network policy, but maybe it's too much. We can do this in another live show, I guess. Just a caveat mentioned here.
Yeah. So I if I can wrap it up real quick, what Grayson is essentially saying is that if you're specified to services rule, you're not actually specifying the rule on these service backend endpoints. You're just specifying a rule towards the cluster IP of the service. So if you really wanted to have complete protection against the service, you probably wanted to protect the cluster IP and the backend communication as well. So, but that's a more sort of like advanced topic for this, I would say.
Okay, gotcha. So let's see if there's any questions in the comments. Okay, I think we can continue to the next session. By the way, hi, Amin. Hi, Zach. Welcome to this live show.
Hey, guys. Okay, so as promised, this live show is about the Antrea policy in action. So let's see some actions. We'll apply the specific policy. And as promised, every namespace is now isolated except for the DNS, right? So let's verify really quickly if that's working as expected. So if I go exec into one of the client pods in the namespace US dev US East, right? And I do a bash. Okay. So if I do a curl on the web deployment of the same namespace, which is this guy, and I'm not too sure what the pod is listening on, but I'm guessing 8080, right? So it's good, right? So I can basically talk to the web pod for my own namespace. Now, what will happen if I try to talk to the web pod of a different namespace, which is this guy? Right? What will happen then? We'll get denied because of the drop rules we have for the namespace isolation. So that's how it works. And as promised, also, we don't regulate DNS traffic, right? So the kube system core DNS is running in another namespace, but we can still talk to that because we have another path rule. So let's try to ping, say, google.com, and it's good. And you might probably ask, we have a egress drop all rule, right? So why does the egress to Google still works? Because you can see here, we can still talk to Google as an egress. That is because in the strict namespace isolation for the drop rules, we're selecting two, and the namespace selector everything means that I wanted to drop the egress of the pods to all other namespaces within the cluster. But it doesn't really specify what's the behavior for all of cluster traffic. So if we change this a little bit, right? If we change this to, let's delete these two lines. If we change to a rule like this, which is basically saying that I want to drop everything else except for these two. And we apply this policy. Now, if we take a look into the same client pod and try to ping Google again. You can see the DNS still works, right? Because we made a explicit allow rule or not allow rule, a pass rule or allow rule for that. So the client was able to receive the resolved address for that specific domain name, which is google.com. But when it sends the traffic out of the cluster, it gets denied because we have a deny all egress policy in place. So this is how this works. Is there any question on this so far?
I'm a little confused. Could you show the YAML file of the cluster network policy again? So before you added it under the drop action, what do we have there? I remember
we have
two
a two and
namespace.
Right.
So it means that with these two lines, we cannot talk to other namespace within, but we can talk to the other service outside the cluster.
Yes, because the namespace selector and everything, this specific class is basically saying that I'm selecting every namespace of the cluster. But obviously, we're not selecting all of cluster items. Right? So what this rule translates to is that I wanted to drop everything to all addresses in the cluster, if you will. Right. But
Okay.
it's not dropping anything to out of the cluster. But if you remove these two lines and just say action equals drop, this is a completely different meaning rule. This means that no matter where the packet is going, you need to drop it because we have a drop all rule, which is a really, really strong rule, basically.
Okay, so for all the traffic to the outside the cluster will be dropped if we don't specify the namespace selector.
Right.
But if we select all the namespace, it just means that we cannot talk to all the other namespace, but we can still talk to the outside the cluster.
Right.
Okay, gotcha.
Yes.
Let's see if there's so. I think we have another question here from Jay. So
Okay.
off topic, but relevant. How do network policy work with non-TCP protocols like ping?
You want to take this question, Grayson?
Can you hear me?
We can't hear you. Yeah, I can hear you now.
Oh, okay. So if you define a network policy without any relevant field towards the L4 protocol, for example, if you want to define this policy, can you open the cluster network policy on the screen?
You mean this guy?
I mean, open the YAML file. Yeah. For example, in the egress, you only define the two as the to all namespace to an empty namespace selector. This will only select all namespace, but you can also define a field called ports. Under the ports, you can define or I only want to drop the TCP traffic or UDP traffic or SCTP traffic. But if you didn't define the ports field, so it will only do the traffic match on the L3 layer. So the ping will also be affected by this policy. But since you mentioned this, if you define the ports, the only support protocol currently is are TCP, UDP, and SCTP. But currently, I'm working on all ports is default. I remember. Yeah, and also currently I'm working on the add ICMP support in the cluster network policy. So you can define it. I only want to drop the ICMP type 8 code 0 or something like this. You can do this in the next version cluster network policy, it will bump up the cluster network policy to V1 Alpha 2. This could be in Antrea 1.7, I guess. Yeah, hope I answered your question, Jay.
Okay, I think you answered his question very well. And Jay, if you have like any further question about this, you can reach out to Grayson to see how
Okay.
yeah, for further questions about this.
Okay. What else do we have? I do also have another thing prepared. Oh, let me quickly jump into this guy. So for this allow dev inter namespace YAML, what I want to do here is that remember we do have two dev namespaces, right? Let's see this guy. So we have dev US East and dev US West, right? So the namespace isolation basically says that all namespace can only talk to itself. But there can be cases where those two dev namespaces, the admin may probably want these two namespaces to be able to talk to each other in addition to itself, right? Because they are all type equals dev namespaces. That's a really reasonable assumption. So what we can do is that we can apply actually a higher order cluster network policy to allow this. So remember the other network policy we had is in security ops tier and priority 5. So this is a security ops tier priority 1 policy, which on the policy level, it has a higher precedence than the previous namespace isolation policy. Now, what it does is that it's applied to type equals dev namespaces, which selects the two namespaces I just described. And in the ingress and egress rules, it's saying that I wanted to allow type equals dev namespaces to talk to me. So what this policy does essentially is that it will not only enable these two namespaces to talk to each other, to talk to itself, which is done in the strict namespace isolation YAML, but in addition, it will allow these two namespaces to talk to each other as well. So let's see how that works. If we apply this policy, and we do a check, which is right now I'm in the client of the US dev US East namespace. And remember when we tried to curl the web in another dev namespace, it was not returning everything because the connection was dropped. And let's see if this give me a success this time. It does. So what I'm showing here is I applied a higher priority policy on top of the strict namespace isolation, so that it overrides the drop rule of the original policy a little bit, if you will, because remember we have a drop rule dropping every other namespace here, right? But the drop rule is being overridden because there are a higher order policy allowing this very specifically in another cluster network policy.
Yeah, that makes sense.
Right. Okay. So let's look at the final policy that I prepared here is the allow AWS for DB. So remember, we have a bunch of app equals DB pods in all of the clusters, in all of the namespaces, sorry. right? So one specific use case might be, these DB pods are actually constantly trying to talk to, S3 buckets or whatever, to, update the entries there, right? And from a security perspective, the cluster admin might want to say that, hey, I wanted these to talk to the DB pods to talk to this online or another CIDR specifically, and that's all I need. For any other egresses, I don't want to allow it because that's not secure. So by this example, I'm trying to showcase the new FQDN feature we added into the Antrea native policies a couple of releases ago. So looking at this policy, we are actually, selecting every DB pod in the cluster, no matter what the namespace is. And we're allowing an egress to this specific FQDN regular expression. I shouldn't say regular expression. I should say FQDN wildcard expression. So that means that every egress request to, maybe www.amazonaws.com or S3 bucket blah blah blah.amazonaws.com is allowed. And the DNS components is also a pass because I do want it to pass to be still able to resolve DNS, obviously. Otherwise, this will be in vain because if a pod can't even resolve DNS, then obviously it won't be able to egress to anywhere, right? So other than these two cases, we drop all egress, which means that you won't be able to talk to google.com or everything else, right? So let's see this guy in action. If we apply this to the entire cluster, it means that now for every pod we have, for every DB pod we have in the entire cluster, which is this guy, these guys, and these guys, we should have the same effect. It can only egress to AWS related components, if you will. So let's double check that. If we exec into, let's do this guy now, DB deployment from production US West, and okay, so we tried to ping Google, which is not supposed to be working. The DNS was working, but the egress request is getting dropped because we have to drop all rule, if you remember. But the www.amazonaws.com should not only be able to resolve the DNS, but the egress should also be successful. Did I do something like this? Okay, let me quickly check what's going on here. We allow AWS for DB. Okay.
If you don't define the ingress rules, so all the pods can talk to this pod, right?
Right.
Do you have other policy in action?
I assume that will be the case. Let me check because I did change these, right? I didn't know if I applied this or not. Okay. Yeah, remember I changed this policy to drop all egress, and it's affecting. So basically we have policies stacked with each other. Now this Amazon AWS being dropped is because there's another policy in place, which I forget to apply, and it's dropping all egress. So that's basically the reason. So right now, if I configure this correctly, and now I go to this pod. Let's do this again. Let's do Google again. It's dropping the egress. And let's do Amazon again. And it's connecting.
Awesome. But I remember that the allow AWS for DB YAML has the higher priority than the strict.
It unfortunately does not. If you
Does
look
not?
at the allow AWS DB, it doesn't have a tier keyword. And what happens is that if an Antrea cluster network policy is not specified with a specific tier name, it will be associated with the application tier. And the application
Okay.
tier has a lower precedence than the security ops tier, which is what we put the namespace isolation policy on. So
Okay,
what
gotcha.
happened is that namespace isolation policy we forgot to change back, and it is dropping all egress for all the namespaces. And so it doesn't really matter what you define in the application tier anymore, or what the FQDN policy put there, because every egress will first be evaluated in the egress in the security ops tier, and there's a rule drop in all egress, so everything will be dropped for all of the clusters.
Oh yes, I just noticed the priority, but I didn't see the tiers there.
Right.
Okay.
So I would say that concludes all the demo we have today. It's really good that we actually run into a small problem now. It really basically shows you how we kind of debug these kind of things, because you will probably also want it every time you see some policies not working or not working as intended. You probably wanted to check what are the other policies that are applied to this pod, and if these policies make sense. And
Yeah, if we have many network policy at the same time, probably it will influence each other unexpectedly.
right.
Okay.
And the last thing, since we're speaking on that, the last thing I want to mention is that for the Antrea agent, we actually have a pretty cool command, which is called exact it. If we go to the Antrea agent in the kube system namespace, sorry, I won't do the it. I would, and if we go to the Antrea agent container and do this command, get network policy, and you provide it with a specific pod name and a pod namespace. It gives you what policies are applied onto the specific pod at the time being. So for client pods, the only policy affecting it is the strict namespace isolation, we just put on. But if we do this for the DB pod, which is this guy in this namespace, you will have two policies because it's affected by the strict namespace isolation, and it is also affected by the FQDN rule. Right? So in here, you can see how these two policies compare to each other. So this FQDN rule has a tier priority 250, and this guy has a tier priority 100. And the smaller the number is, the higher the precedence it will be. So this policy's tier has a higher precedence than this policy's tiers. So this policy will always be evaluated first. And if there's not a match, or if there's a pass, for example, then this policy will come into play, if that makes sense.
Yeah, I think that's a really powerful way to debug the network policy, because sometimes you maybe forget it, which policies are applied to this pod.
Right.
Yeah. Thanks, Yang and Grayson, for like showing us the Antrea policy today. I learned a lot from your like demo, and hope like our audience also have an idea of how to use the Antrea policy from watching our show.
Okay.
So
Thanks.
so for
let me stop share real quick, if that's okay, and I will run through if there are any questions I haven't answered.
I think we're clear in the comment place, and where like there's like no time left for this show.
Right.
Thanks everyone for watching, and if you like this kind of context, please consider liking our videos and subscribing the channel. And next week, Jay will be back and to host the next one, and see you next Wednesday. Appreciate your time. Bye everyone.
Bye.
All right. Bye.